Example 5. In 2016, the rates for a taxi ride in Macon, Georgia was $1.20 for the first mile or part of a mile and $1.20 for each additional mile or part of a mile. Determine a piecewise function, g of x, for the cost of a taxi ride up to 5 miles. So we need to come up with a piecewise function. So for your first one, you know it's going to be $1.20 when you go up to 1 mile. So for our domain on this first one, we're going to say between 0 and 1 mile. Now, we know that if we're riding in a taxi, we're going to go more than 0 miles. So this would be strictly greater than 0. 0 is not included. But we are going to include 1 because we are going up to 1 mile. Now, our next equation is going to be another $1.20 added to the first $1.20. So $2.40, and that would go between 1 and 2 miles. Now, since the 1 mile was included in our first equation, we know that in our second equation, 1 cannot be included, but 2 is included because we're going up to 2 miles. So what's happening here is we are describing how much it's going to cost for how long we ride in the taxi car. So right now we can see that if we go anywhere between 0 and 1 miles in the taxi car, it'll cost $1.20. If we ride between 1 and 2 miles, it's going to cost us $2.40. Okay, so the next one, if we take $2.40 plus another $1.20, it would cost $3.60, which would be between 2 and 3 miles. 2 cannot be included. 3 is included. The next one is $4.80. That would be from 3 to 4. 3 is not included. 4 is included. And then $4.80 plus another $1.20 would be $6. That's between 4 and 5 miles. 4 is not included. 5 is included. Now the instructions wanted us to go up to 5 miles, and we did. So this is our piecewise function. It says, what is the slope of each interval? Well, before we answer that question, let's go down and graph this and see what it looks like. So we want to graph for less than 5 miles. So on my graph, in between 0 and 1 on the x-axis, I should have a line at $1.20. So on your graph, you're going to do your best. Okay, 0 was not included. 1 was included. I'm going to have to zoom in here a little bit. Okay, so $1.20 is about right here. Okay, we have an open circle at 0 and a closed circle at 1. And we have a line. Okay, now our next equation was $2.40 from 1 to 2 miles. So we have an open circle and a closed circle with our line. Okay, and then the next one was $3.60. $3.60. And then $4.80. And then $6. And keep in mind, if you look at the instructions, that it says less than 5 miles. So we would put an open circle right here on the 5. Okay, here's 5. It wants it to be less than 5, so we would not put a closed circle. Okay, so this is what your function looks like when it's graphed. It asks on part B, what is the slope of each interval? Well, if you look at the slope, it's flat, 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 flat. So the slope of each interval is 0. Okay? The slope is 0. There is no slope. If you move down, it says describe the graph of the function as either increasing or decreasing. So even though each piece has no slope, we can tell that the entire function as a whole is increasing okay? You have just graphed a step function. A step function is a piecewise function whose pieces are disjoint. That means they are not connected, and they are constant. Okay, go ahead and flip the page. We're going to do one more step graph. Okay, write the step function f of x to describe this situation. Then use a calculator to graph. You are talking about postal rates. First class mail. Okay, the first one says a letter weighing up to 1 ounce will cost 45 cents to mail. So let's think about the domain. You know that your letter is going to have some weight. So automatically it's going to be between 0 and it's going up to 1 ounce. Okay, so we're writing our domain. If it's going up to 1 ounce, that means 1 is included. And 0 would not be included because you can't have anything that doesn't weigh unless it's an email. Okay, but this is mail, so it's going to weigh more than 0 ounces. Okay, the second one, a letter weighing more than 1 ounce and up to 2 ounces. So we're between 1 and 2. 1 was already included in the first piece, so not included. And we are including 2 because it's up to 2. Okay, the third one, a letter weighing more than 2 ounces and up to 3 ounces. 2 is not included, 3 is included. So those are your 3 domains. Now let's think about your equations. Okay, the first one, it'll cost 45 cents to mail. So no matter what, if it's barely over 0 ounces and if it's clear up to 1 ounce, no matter what that weight is, it will always be 45 cents. Anything between 1 and 2 ounces will always be 65 cents. And anything between 1 and 2 or 2 and 3 ounces will always be 85 cents. Those are your 3 equations. So in your function, you're going to have an equation that says 45 cents, an equation that says 65 cents, and an equation that says 85 cents. And then you're going to write your domains. And there you have your function. Now I'm going to draw a different graph off to the side because I feel like it's going to be hard for me to graph on this iPad with the graph that's given. So what I'm going to do is create a graph. Okay, I'm going to call this my x-axis, 1, 2, and 3. Okay, this is representing the ounces, how much the mail weighs. And then I'm going to, on the side, put 45 cents, 65 cents, and 85 cents. This is obviously representing the money. Now, what needs to happen? We need to graph our step function. So we know that from 0 to 1 ounces, it's going to be 45 cents. 0 is not included, but 1 is. So you should have an open and a closed circle. Okay, from 1 to 2 ounces, you have an open and a closed. And from 2 to 3 ounces, it's 85 cents. Okay, so this here is our step function. We can see that it's increasing. The slopes of each piece is 0. Okay, you are able to graph this in your graphing calculator. I will not make you do this, but just in case you are interested, in your graphing calculator in Y1, you would type 0.45 divided by parenthesis 0 less than x, parenthesis x less than or equal to 1, parenthesis. In Y2, you would type 0.65 divided by parenthesis 1 less than x, parenthesis x less than or equal to 2, parenthesis. Y3 would equal 0.85 divided by parenthesis 2 less than x, parenthesis x less than or equal to 3, parenthesis. If you are wondering how to find the less than and less than or equal to symbols on your calculator, you need to hit your second button, then hit the math button, and then you should see your symbols. You've got less than, greater than, less than or equal to, greater than or equal to. This concludes the second part of 9.1.